This video explains how we name straight chain alkanes. A straight chain alkane is simply a compound that's made of carbon and hydrogen and all the bonds are full. A saturated compound. These are alkanes that we made last class. Here you can see all of the alkanes from C1, one carbon, up to C10. One of the questions probably is, why do we call them straight chain? Because all the carbons are connected together in a straight line. Okay, now sometimes it may not seem like that if we look at one of the longer hydrocarbons. Excuse the camera and the hair. If we look at one of the longer hydrocarbons, such as this one, which is C1, 2, 3, 4, 5, 6, 7, 8, 9, 10, C10, we can actually make it look as if it isn't a straight chain. By just simply bending some of the bonds, or angling some of the bonds slightly different. But this is still the same structure as wrestle, as that, and as that. Okay, all 10 carbons are still connected together in a straight line. Even if the line actually goes around a corner or has an angle, it's still considered to be a straight line. In order to name organic compounds, we have to be able to count in chemistry terms. Names are based around the number of carbons in the longest chain. So if there is one carbon, that has meth, the name meth, and then the ending to tell us what the molecule is. So methane in this example. 2, eth. 3, prop. 4, bute. 5, something a bit more familiar, hopefully, pent. 6, hex. 7, hept. 8, oct. 9, known. And finally 10, dec. So here's our first compound. This is one carbon. Its name is meth. Methane. And we can represent it like this. We can represent it with a Lewis dot structure, also known as a structural formula, and we can also represent it with its chemical formula, CH4. This molecule has 2 carbons, one here, one here, joined together. That's 2 carbons. Its name then is ethane. Okay, the structural formula. Each one of these has got a hydrogen. Not quite sure my H's and things are turning out like this, but that's okay. Okay, whoops. Or we can also do this, instead of drawing it all out longhand, we can also do a condensed formula, which would look like this, CH3, CH3, and we can also do the molecular formula, C2H6. And that's because we have two carbons. 1, 2, 3, 4, 5, 6. This compound has 1, 2, 3 carbons, whoops, 3 carbons, and 1, 2, 3, 4, 5, 6, and then just behind here 7, 8. They're a bit harder to see, but they are there. 8 hydrogens. Okay, and again we can draw the structure. We'll do the condensed structure again here. CH3, CH2, CH3. Or we can do, if we want, let me change the colour of the pen so we can see it on here. Carbon, hydrogen, 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 carbon, hydrogen, hydrogen, carbon, hydrogen, hydrogen, and then hiding back there, hydrogen. Okay, that's the structural formula. All of the same thing, and the name is propane. Okay, this one has 1, 2, 3, 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen. So C4H10. Okay, and again we can do the structural formula, joining all those together, and we can also do the condensed formula, CH3, CH2, CH2, CH3, and the name, that's right, butane. Okay, next one. 1, 2, 3, 4, 5 carbons. So that's C5. 5 carbons is pent. So this molecule is going to be called pentane. And it's going to have the formula C5H12. And its structural formula, condensed, CH3, CH2. We can condense it even more actually, because there's going to be 5 carbons. So 1, 2. Okay, one on the end, that's 2, and then in the middle there'll be 3 more. So we can do it that way as well. All mean the same thing. Okay, so that means the same as CH3, CH2, 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 CH3, which also means the same as drawing all of this out longhand as well. Okay, this is the C6 compound. Again, this is a straight chain carbon, hydrocarbon, but I've been a bit naughty and I've bent it round just to fool you a little bit. We have 1, 2, 3, 4, 5, 6 carbons. C6. H14. Name, hexane. Okay, and formula, formula CH3, CH2, 4 times, and then CH3, which of course I can't fit on my thing now. Whoops. There we go. 7 carbons. Heptane. Heptane has the formula C7H16, I think. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Whoop, yep, 16. Okay. C7H16, heptane. C1, 2, 3, 4, 5, 6, 7, 8. C8, H18. Okay, CH3, CH2, CH3, CH3, CH2 6 times, CH3, or if you prefer, 1, 2, 3, 4, 5, 6, 7, 8, and then hydrogens coming off each one of these. My drawing's not that good, sorry, but there we go. Okay, and you must put the hydrogens on, and they must point and end in the right places, all the arrows. Okay, you get penalised for a lot of things on these. Okay, and so on and so forth. And here at the top we have C9, nonane, and at the bottom we have C10, decane. Okay, now if you remember, we asked you to draw straight chain alkanes, or we named straight chain alkanes. Why do we insist on straight chains? Well, because, well, this is C4, 4 carbons. We would call it butane, but there is another possible structure for butane which still has 4 carbons joined together in a straight line. Well, almost in a straight line. This is the other C4 possibility. Okay, this is what we call a branched hydrocarbon. Okay, they both have the same molecular formula, C4H12. Okay, you can count them if you want. 3, 6, no, sorry, C4H10. Whoops, C4H10, I should know that. And this one here is also C4H10. They're called isomers.